Now we want to start actually delving into the domain of functions, right? Yeah, we took the last two sessions to talk about the type of numbers that we'll be talking about, right? We took our time to also explain to you what domain of a function is. So basically, we say that domain of a function refers to, um, let's use an analogy rather. If you have, we are looking at functions as a machine that you put something inside it, then something comes out. Every machine, like if you have a mobile phone, there are set of things that you can do that you can put inside the mobile phone to get a particular output, a particular result. The same thing applies to every other machine. So there are functions. If you see functions as machines, right? The set of inputs that are allowed to go into a particular machine, right? Those anything that is um, qualified to enter that particular machine, we call them domain. So the same thing. If you have a function, there's a set of inputs, a set of defined input that can go inside and make the function work or make the machine work to give you a result, right? So those things we call them domain. We took our time in the previous session to do that, and we said that among all the numbers that will be put inside these functions, the numbers that we'll be focusing on will be real numbers, which were explained in the previous sessions. And also, we had to take time to explain to you what domains are. So in this session, we are going to start with domain of polynomial functions in general. Domain of polynomial functions. We look at what polynomial functions is, but then basically, simply for WASI students, right, and for WAEC, the type of questions that come, the type of areas that they set in. So they want to impart a particular knowledge when it comes to domain in three particular areas. But the key features of the type of questions that come is what we are going to bring out to you today and tackle. And then we start with polynomial functions. So generally, based on all the classification that will give you ideas on previous ones, domain of a function, we want to, when you come to domain of a function, there are three key feature functions that you have to actually identify, right? Short stands for Scholar Opportunity Nexus Test. This is a daily test that we organize for our students that are with us on vacation. This is to make sure that we are able to time and test them on a live platform in the first few minutes of daily sessions. Every day we teach them live. Every day we discuss concepts. But before the beginning of every session, we make sure that we test them in a few minutes, review the solutions, mark it for them before we begin to start a particular session for a particular day. Anything to sustain the academic dream of this student, SAN is ever committed. So the type of function that we're looking at are functions. Some of the functions contain the division sign. Some of them contain the division sign. Some contain the radical sign. Radical sign. So that's what you will be seeing, the square root stuff. And then some contains both the division, contains both. So the division sign is this symbol. Let's say function 1 divided by function 2. There's a kind of division inside, right? But radical function, they contain square roots, and the functions for both, you can have both like this, yes, or you can have function 1 over function 2 in division form, or you can have it like square root of function 1 over function 2. You have both the division and the square root sign inside, but there are some that they contain none of those two. None of those two. They don't contain, they are just functions like straight like that. Function 1 plus function 2 plus function 3. None of them contain the square roots and the division sign, right? So when you look at it, when they give you a function to find the domain of that function, first try to look at what form, the form of the function, whether it has a division sign, it has a square root sign, and those stuff, right? Yes. But the first we are going to focus on, we are going to take it step by step and focus on the one that don't contain any function. I use that to explain how to generally write domain of a function. So any function that you have, let's say f of x, so the input function is x, right? And I just give you 3x. For this particular function, we are asked to find the domain of this function. Remember, domain, we need to actually specify that the function, the number that we're focusing on are real numbers. So first you have to say that the input, which is x, right? X should be an element or should belong to a real number. It should be a real number. but then they are a set. There should be a set. So for that reason, we need to put it in this bracket, this curly bracket. Curly bracket means set, a set. If you have done set and operations, you see that this particular sign means that a set. So domain is equal to the set of x is a member of all real numbers, right? That's what we have here. This is how to express the domain of this particular function. So here we don't have the division sign, we don't have the equal to sign, and yes, that's all we have, right? Okay, let's look at another example. I have f of t is equal to 3t squared minus 5. And I have this function again. There's no division, there's no square root. Fine. So what do you think will be the domain? So the input function, right? The input function, which is t in this time for this particular function, the input is t, right? Is should be a member of all real numbers. Basically, that's it. So you have to state that the domain is equal to this. This is the domain for this particular function. So all the input that can go inside should be all real numbers, or t belonging to all real numbers. Okay, let me give increase the this in a bit. I have 3x plus 4 x squared. So for this particular function, we are asked to find the domain. There's no division sign, there's no equal to sign. But then what is the input function? We have the x here. But then in this particular function, we talk about this, how to identify the input variable. So the input variable is t, not x. So x here are not the input, so they are basically constant. But then we have to focus on the input variable. T is a member of all real numbers. Yes. So there's no division, there's no square root. This is how the function comes. So we keep it as how it is, and this is just basically the domain. T is said that t is a member of all real numbers. Okay, so now let's write it formally. You don't just write it t is a member of all real numbers, t is a member of all real numbers. Formally, for all these things, you have to say domain is equal to the set. Is going to be a set x. Let's say the input variable is x. X is such that x is a member of all real numbers. So capital R is all real numbers. We actually write it with double beginning bars, right? You do the double line like this before you close it to the R. But then if you do it, X is a member of capital R, is accepted, right? All real numbers. That's what we assume is capital R for all real numbers. So yes, so remember this is how it comes. X is such that X and a double sign, the double sign. Remember, it can be T. If T is the input variable at that time, you can say T is such that T is a member of all real numbers. So this is for functions that are just straight. You don't contain the division sign. They don't contain the square root sign, that's the radical sign. But then you have to be careful. Let's focus on another function. Let's call it g of s this time. And g of s, I say, is 3s squared minus 5t all over 5. So for this particular function, you will see that there's a division sign. Does it mean that the thing will change? Here again, you have to know that yes, containing division sign and radical sign does not guarantee that it's going to take a different form. What you have to focus is that what's the input variable? The input variable is x, right? Where is x? Is x under the square root, under the denominator, right? So here we see that our input variable is x, and x is at the numerator. So when x is at the numerator, then we don't have any problem. Even though there's a division sign, we don't see our input variable anywhere at the bottom or at the denominator. For that reason, it's treated as a polynomial functions. A function. So the domain is x is such that x is a member of all real numbers. Still, the domain is like that. We write it like this. Even though this one contains division sign, what happened? The input variable, which is x, is not at the denominator. It is not at the denominator, so we are safe, right? So it's technically the position of the variable that is actually going to change how the domain will look like. But in this case, the input variable is at the numerator, it's never at the denominator. If it is at the denominator, that's where we'll have to tackle it from a different angle, which we'll look in the previous subsequent sessions. But in this session, we are seeing that it is not. So even though it contains the division sign, we are free because our input variable is at the numerator, not the denominator, so it's safe. The same thing will apply to something like this. Let's say h of x is equal to x square root of 5. You'll see that these divisions are in this particular square root, it contains square root as well, but then our input variable x is not under the square root. It is not under the square root. So for this particular thing to the domain is x is such that, remember, x is such that all the time x is a member of all real numbers. That is how to find the domain of this function. The reason why we are stopping here is because our x is not under the square root. Our x is not under a particular division sign or as a denominator. So if it is, if our input variable is not in that a case, right, we do this. Let me do a last function for you. Let me call it m of x. A function called m of x is equal to 3x plus square root of 3 all over the square root of 3t, like, yeah, 3t all over t squared minus 5. So you see that you have to focus. Remember, be vigilant and focus what the input variable is. The input variable is x. So the input variable is x. So you have to look at where the input variable is inside the expression. Our input variable is as a numerator. If you focus on if t were the input variable, that's when we'll be seeing that, oh, our input variable is at the denominator. But in this case, our input variable is x, and x is just a numerator. Since it's just a numerator, we are safe. It is not it is not found in the denominator, and it is not found under the square root. If it's not found like that, what do? We just say the domain is equal to the set x is such that x is a member of all real numbers. So technically, our classification, how we look at it, is that functions that are just polynomial or functions that are just straight. In those functions, the input variables is not under a square root and under a denominator, right? And for those cases, you are safe. So we just stop there. X is such that x is a member of all real numbers. Let's move forward and see how to tackle cases where x is either under a square root or denominator. Thank you, and see you in the next session.